So again, when we start talking about word problems, we've got the same idea that we've sort of been addressing over and over again. The first thing we have to do is make translations. And again, in this case, at this point in your math life, you need to learn to relate two unknowns so you can just use one variable, because we do not know how to solve equations in more than one variable at this point. So as always, we name the first integer or the first thing x, and then when we were doing the number problems, we had to name the second integer in a way that related it to the first integer, and again with the third. So generally we name the first thing or the first integer x and the second integer based on the relationship to that. Now this is a basic example of how we can do this. Now this one is pretty basic. It says a length of rope 45 feet long is cut into two lengths. The length of the first piece is 2 times as long as the first. So the first thing that we do is always, draw a picture. And this is without fail. So how do you draw a piece of string? Well, very carefully. And my piece of rope, rather, is going to look really horrible. Okay, it's frayed at the end. And there's our piece of rope that disappeared. There's our piece of rope. All right. Now it says that the length of the second piece is 2 times as long as the first. So it's saying pretty specifically we cut it into 2 pieces. Here's the first piece, and here's the second piece. So we're just doing it bit by bit. This isn't, so far we haven't used any math. We're just using critical reading skills here. So length of rope cut into 2 pieces. We know that the entire length is 45 feet. So again, haven't done anything interesting yet. The length of the second piece is 2 times as long as the first. So the length of the second is 2 times as long as the first. So we have length of the second piece is, and then what is the second piece? 2 times as long as the first. So generally speaking, and again, this is a generalization, so does it work 100% of the time? Probably not. But does it work virtually all the time, at least in this class? I'm going to go with yeah. So when you look at this and it says that one piece, the second piece is, that is a nice little divider for us. And whatever follows it is telling us what we're going to do. This is our x. So the first piece is x. The second piece here that we're talking about is 2 times, and we said our first piece is x, right? So it's 2 times x, otherwise known as 2x. So we, labeled the picture, and then we labeled the variables. Now, notice that I didn't take, I'm not going to redraw the picture every single time, but this is literally what I will do every single time. I will draw a picture and then start labeling it with what we know. We label the first piece, and the key here is making sure you recognize what the basic one is. It's usually the thing that's following that is. The second variable, or the one that we have to do something to, is usually the one that is stated first. Now, the next thing that we can do is we can write an equation based on that information. So the equation is, we know that this is x, we know that this is 2x, and we know that the total length is 45 feet. So we have, x as the first piece plus 2x as the second piece is a total of 45 feet. And now all we have to do is solve. So we combine like terms, divide out the coefficient. So now we know that the first piece was 15 feet long. We go back to our picture here, to our word problem. It says, what are the lengths? So we know that the first length is 15 feet. So this one is 2 times 15, which is 30 feet. So the first piece, 15 feet. The second piece, 30 feet. So that's the basics on how we do this. Now we need to be able to do the same thing when we start working geometry word problems. And we really are going to deal with just really maybe 3 basic types. We're going to talk about this idea of the complementary or supplementary angles. You'll see that again in the next class. We're also going to talk about perimeter of a rectangle and perimeter and angles of triangles. So I guess there's 4 types, but perimeter is pretty straightforward. So let's go ahead and take a look at our first version. Here we've got a angle problem, and again we are relating one angle to the other. So here's our problem. It says the second angle is 15 degrees less than twice the measure of the first angle. These angles are complementary. Find the measures of the 2 angles. So this is the information. We know that we're looking for both angles, and we know they're complementary. So as soon as we know that they're complementary, we know, and this pen doesn't do I don't do a great job writing a perfect right angle, but believe me, I'll put that there, and now that tells me that this is a right angle. So you're going to have to trust me on the right angle thing. Now it says that these 2 angles are complementary, which means there are 2 angles that make this up. And all I need to do is split that. And now I've got, what are we calling it? First angle. And here is the second angle. So that's all we need to do to label those. We know that the angles are complementary. That means they add up to 90 degrees. Now let's go back to this beginning sentence here where it says the second angle is 15 degrees less, that's a minus, than, remember, is going to switch the order, twice the measure of the first angle. So we've got all this complicated stuff that's talking about the second angle. So the first angle, that's my x. This one we had 15 degrees less than twice the first. So twice the first is 2x. The than is switching the order, so that's 2x. It's a subtract, minus 15. So again, make sure you go through that so you understand where that 2x minus 15 came from. These angles, again, are complementary. So we've drawn the picture, we've labeled the picture, and now we're going to write an equation. So our equation is, we know that the 2 angles add to 90 degrees, so we take both angles and we add them together. So we say, here's our first angle, and our second angle is 2x minus 15. And those add up to 90 degrees. So we've got our equation written. We know that this is the first angle, this is the second angle, and 90 is what complementary angles add up to. Complementary. There we go. And now all we have to do is solve. So we take our x plus 2x minus 15 is equal to 90. We combine like terms, so we get 3x minus 15 is equal to 90. We get our variable alone. Now, what you should be noticing at this point is now we're doing the math. Setting it up is a critical reading skill. This is our math skills. So go 3x is equal to 105. Divide that by 3. And x is equal to 35. I'm going to slide back up here and say, all right, well, here's our picture. And we need to make sure that we're answering the question. So the first angle is 35 degrees. And now it says we want the measure of the two angles. So we need to do this one. So this is 2 times 35 minus 15. 2 times 35, and of course this is just order of operations. 2 times 35 is 70. And 70 minus 15 is 55 degrees. Now the next thing that we want to do, and I don't actually have this listed, but it is something that you should always do, is check to make sure that it worked. So how do I check to make sure it works? Well, I know that these angles are supposed to add to 90 degrees. So we do 35 plus 55, and the question is, do those add to 90? And the answer, of course, is yes. So we know that we're good to go. Okay, so let's go ahead and do this. This says the perimeter of a parking lot is 5,000 feet. So a parking lot, and we are going to assume that it's a nice rectangular parking lot. And it says the perimeter is 5,000 feet. It says the length is, so remember that means that our width is our x. The length is 200 feet less, so I'm going to subtract 200 feet from something, because that than is switching the order. And then we've got twice its width, and twice its width is 2x. So that should look sort of familiar. Now, of course, the next thing that we're going to do is we are going to write a formula that works for this. And this is the perimeter of a rectangle. The perimeter of a rectangle is perimeter is equal to 2L plus 2W. And yeah, you do need to know some of these basic geometry formulas. So now we're just going to plug it in. So the perimeter is 5,000, and it is 5,000 feet. We'll worry about that later. 2 lengths is 2x minus 200 plus 2w is x. And now we just start simplifying so we can go ahead and solve it. So I'm going to distribute. I'm going to combine like terms. Going to get my variable term alone, add in the opposite. And when I divide out the coefficient, I get x is equal to 900. So my width is 900 feet. Now, it says the dimensions, so that's telling me I want both. So I'm going to do 2 times 900 minus 200. 2 times 900 is 1,800 minus 200. And that, of course, is 1,600. So our length is 1,600 feet, and our width is 900 feet. So let's do another rectangle. We've got the length of a rectangle, and again, it's telling us that it's a rectangle. So the first thing I do before I even get anywhere is I draw the rectangle. And it's the length is, so we know our width is our x. So the width is x. And no, it's not always the width and the length treated this way, but the two examples that we have just happened to be in that order. And then it says is 4 meters less than. So we know that the order is going to switch. 4 meters. We're subtracting. So what are we subtracting? X and 4. And then it says the perimeter is 40 meters. And now I have to find the length. So the first thing that I'm going to do is write my formula. So perimeter is equal to 2L plus 2W. And now I just plug stuff in. So perimeter is 40 is equal to 2 times, and length is x minus 4, and w is x. And now I just start solving. So nothing spectacularly interesting going on here. I use the distributive property. I then combine like terms. I add the opposite of the constant to get my variable term alone. And I divide out the coefficient last as always. And I get x is equal to 12. So my width is 12 meters. And then the next thing I do is it says that I want the length. So I'm always going back to the question to say, what am I supposed to be doing? What am I supposed to be looking for? So it says I'm looking for length. Well, I have found width. So length is 12 minus 4, otherwise known as 8. So the length is 8 meters. And that is the solution for that.